All right, again, welcome everyone. We're so happy to have you here today for our graphics and GUI projects with coding rooms. One of the things I really love about coding rooms is their support for graphics and GUI projects. When it comes to online developing environments, I haven't, yes, you are, and this will also be recorded. Someone threw a question there. This will be recorded and uploaded to YouTube. But one of the things I really loved about coding rooms is I really enjoy having students generate GUIs and do some graphic stuff, because it really brings coding to life when they can see something that they're used to, actually interacting with when it comes with software. They're used to using a graphic user interface. So what I really loved about coding rooms is the performance and the reliability of graphics projects on the platform. When it came to any other online developing environment that actually supported graphics, it's hard to find ones that actually support generating a GUI. But the ones that exist do not work as smoothly and just as reliably as coding rooms. So I really praise the product for that. It works. I truly say it works just like if you were just developing locally on your Windows or your Mac computer. It feels that natural. So if you've done any of that with local IDEs on, in your computer lab previously, this is going to work just as beautifully, and it works just great on a Chromebook or any device that a student has access to the internet. They can actually develop and render their GUIs, which is fabulous. So today, what we're going to end up doing is we have two guests, technically three, but two main sections with three guests. First, we're going to check out Java projects. So we have two coding languages we're looking at. First is going to be Java, and Lewis Fleming, a very experienced CS teacher at Andrews High School, is going to showcase working with your students in Java coding to do some graphics. And then second, we're going to have Barry Lindler, who's always amazing and fabulous, CS teacher at Dutch Fork High School. And we have a special guest, Mr. Lindler's student, Noah, who's going to showcase a Python library that he's actually created called PyDraw. So they're going to be showcasing wonderful things you can do with Python, as well as a student-developed library you can use with your students to really do some great graphic stuff. All right, so we're going to start off first with Lewis Fleming. As I had mentioned, Lewis has put in the chat, if you want to go over to the chat, a live classroom. If you go over to the live classroom, there is no need for a Coding Rooms account. You can just click continue and you can stay as an anonymous user, or you can log in with a Coding Rooms account. So go ahead and give that a try. And Lewis, if you want, you can start to share your screen for Coding Rooms when you're ready.
Okay.
Although Lewis is going to share his screen, that's mainly for the purposes of our recording. You will actually be able to check out what he's doing and code and run things on your own right within the live classroom. That's one of the fabulous things about Coding Rooms, if this is a newer experience for you, is the live classroom feature allows you and the students, you guys acting as the students today, to see everything that the teacher is doing in their coding workspace, as well as the students can do things in their own coding workspace.
I started with graphics about, I think, 21 years ago in the days of C++. And one of my biggest failures was the year that my oldest daughter was a freshman. She put together, using arcs, circles, trapezoids, built the Grinch in a sleigh with flashing lights. And this was when the kids' accounts were saved on the computers. Went to summer, I went back up there to clean in my room, prepare for the fall, and they had replaced my computers and her code and her computer. We tracked it down and gone to the middle school, and the day I found it, it had been wiped a week previously. And I developed it originally as a Christmas project, and we did a picture. And then fast forward, and what I have over here in the live classroom is from the A+ curriculum, and they have a basic lab that does a smiley face. And it starts off by giving the kids the yellow circle. And so I used to use this, and then we'd go on and we would build our picture. Well, the kids got to where their smiley face ended up with mohawks, and they wanted to do more and more, and wanted to go, you know, well, can we do this on it? I said, I'm just trying to get you the basics. The this part of the lab comes done. They draw two ovals for eyes, an oval for the nose, and an oval for the mouth, or excuse me, an arc for the mouth. And the hardest thing to get them to do is to settle down, because they get the eye, and obviously the first time they try the numbers, it's not on the face. Nor is it the second, or the third, or the fourth. And so I told them, I said, let's start in the top left corner. So make the first two numbers of your code 100, 100. Let's get the eye the right size. And I mean, I've had people who will delete and erase code 100 times. And then I had a kid who I was right the first time, and he followed the instructions to move left to right, change the X coordinate only, and keep running the code till it is positioned left to right. Then change Y to move it down. Arc is one of the harder ones for them to do. So we start by getting an oval in place. And then once they get the oval, I explain how the last two numbers of arc will cut from the draw oval, will cut just a piece of it. And pretty soon, you know, one of them will hit the number combination, says, well, my smiley face isn't happy. And they've managed to get an arc that's upside down. And they had so much fun with the freelancing that I quit doing the Christmas picture, and we went to a full-blown build your own emoji. And on a normal year without hybrid and COVID and everything else, this usually hits early October. I did some different stuff this year. I used Giroux. I had a heavy special ed population, so we didn't move as fast as we normally do. But hopefully this showing the graphic now.
Looks great, Louis.
Yeah. This one of my freshman girls. This is 100%. Every single inch of it is the hardest command that we do, which is polygon. And she coded it out. Another of the freshman girls.
And what course is this, Louis? Just to give us this is like your CS1 type of your first intro course?
This is first year CS, and a couple of these projects were done from 2 years, or no, fall of 19. And that year, everybody was doing graphics by early October. So I choose, you know, I teach them, here's how to do print line, here's how to do a few things. And then I figure if they're going to learn to call methods with parameters, and let them use methods that they're not having to write. And so I show them how to do the basic commands. And that's this year. This one was from October of 19, one of my freshmen. This is from a freshman this year. This is from my overachiever who basically 2 weeks before everybody else was finished, he was at this stage. We experimented trying to make it, we were going to make the missiles flash, but we never could get the time delay. What was a nice time delay on a standalone IDE wasn't even close to, I mean, you could even tell it flickered because of the online processor or online IDE. I basically just guide them and say, the more you graph, the easier it gets. This kid graphed on graph paper for 2 weeks. Came up the last week. I was panicked because he had graphed out to a screen width of 1,000, and the default window on the graphics that I give them is 800. And I showed him, I said, that's carryover from when we started. I said, you adjust this number, adjust this number. This one came in just under 500 lines of code. He had been in coding rooms 2.5 months when we ran this one. Another of the this one, these two guys were juniors. One of the things they get is on the rubric I use is a bonus for a lot of points on the polygon. So I always have them download their code so I can put it in search for, I give credit for creating custom colors. I give credit for creating some other things. And I don't want to overlook anything. And so I saw his picture. And I thought, boy, he did a polygon, but he actually did this all out one line at a time. His polygon are the spider's legs. I think that's the end of them. It is, we've progressed a long way from a house with a tree and a few Christmas lights on it to getting artwork like this. This is a standard Java library. Basically, it is the same code, very similar format to this. That runs smiley face. It's just the one thing I did, because I discovered that the longer the code gets, the more likely a kid is to delete code that he didn't need to delete. And so I created 3 methods: head, face, and bling. Told him, I said, this will help you organize, because sooner or later you'll miss a day of school, and then you'll come back and you'll try to remember, I need to move the earring, and you don't have any idea which line of code it is. If you put it in the bling, you're less likely to erase something off the face. And so the rubric requires them to have code in the 3 major parts of the method. I give require arcs, ovals, rectangles, at least a 3-point polygon. For the weakest students, we get penguin pictures with or people with a dunce hat. And as you saw, we get some polygons that are just crazy with the shading and everything else that they pull off.
Louis, could you go over in the coding rooms area? I want to show a couple things to people while they have this workspace open. So when you go into the workspace, you'll see, click on that tab, Louis, My Workspace.
Yeah.
You may see these 2 windows open, or you may just see the presentation. So if you go over to that tiny URL that you opened up, you may want to open up the presentation and My Workspace area.
I've got presentation in My Workspace open.
Yep. And so show them, Lewis, over on the left there, where your main Java in the presentation.
Right.
If they click on the little icon of the paper with a fold on it, they'll actually see the files over on the left side there.
The sync all.
All the way over on the left, the little icon with the paper and the fold in the corner. Left a little bit more.
This?
Yeah. If you click on that, yeah.
Ah.
So that's where you'll see each of the files. So you should have 3 files, everyone.
Right. Okay, there we go.
And Lewis, do you want to talk about mainly these 2 files that people can kind of check out that you've added for them?
Yeah. The graphics runner is actually, I did a modification of it. They had just one method to put their content in. I modified it to 3, and actually this one okay, smiley face, yeah. The public void smiley face window, and what I had them do when we added the extras for emoticon was they had to call face or head, face, and bling right here. And that was strictly for the purpose of organizing their code. The graphics runner is, like I say, is basically what I got from the labs from 8+ and just modified for my emoticon. You can see here these are all standard Java AWT
yeah, so
imports.
To do these projects, we're just using the regular Java graphics libraries that come built in with the standard install of Java. So no special jars or anything like that.
And then on the runner, just the single import for frame, imported JFrame. And I have used variations of the emoticon project now for, well, in this format with the 2 files, I have been doing it in Java since about 2004. We swapped over from C++ in 2003. I may have skipped out the first year, but the second year we definitely started doing, because that was when I changed curriculum. And the smiley, the kids going freestyle on the smiley, they weren't content to do, is really what developed the emoticon project.
So Lewis, just to spare some screen real estate, now that people see how they can open up the presentation and My Workspace, click on that My Workspace tab at the top there, and we'll get rid of that. And then open up the files area on this one, on this presentation one. Excellent. So down below, once you, if you click the little drop down, everyone, and select run, you can run the runner file. And then when you click view desktop, you'll actually see the desktop area where the graphic generates. So just like if you were on a normal laptop computer, PC, Mac, you would end up, the GUI would just pop up after you run it in the IDE. This just has a desktop area for you to actually see the instance, the Linux instance that the code's actually running on, and you can actually see the desktop of it and interact with it.
Mine just froze up.
No problem.
There we go.
And so you should be able to click that drop down just like Lewis did and run the graphics runner. And when you click view desktop, when you hover over that, there's actually an option to open it in a new tab and not see it in the little viewer. So if you want to see that desktop really large, you can kind of do that a little bit more, you can hover over that and open it in a new tab to see it in a larger view. Great. We have a great question. Someone says they often want to get rid of the camera mic area on the left. And you can do that. I'll have when Lewis goes over. So you see Lewis opened that desktop in a new tab. And so you can see it nice and large. So if your students are developing something like a game, that's a much better thing. Over here, the conferencing area, we left this on. You can actually turn it off when you create a live classroom. And I can help anybody out towards the end of the webinar if you want to show that. But you can, if you leave it on when you created the live classroom, click on that conferencing tab again, Lewis, up at the top. It actually creates a small draggable window that Lewis can actually just drag it off to the side if he wants, off the screen, move it anywhere he wants, just drag it off the screen if you don't want to look at it anymore. So any of you on your own computers, if you don't want to look at that because we're really not using it, you can just drag that right off the screen and just leave it there. And it's gone for now. And if you do need it to come back, let's say you just did that for the meantime, you can actually click the conferencing tab again and it comes right back. So it's not gone forever when you drag it off. Go ahead, Lewis, click on that files area again. And could you demonstrate for us just adding like a smile to the smiley face or an eye or something like that?
Okay.
So then your student can, as Lewis just kind of showed, can make some edits to their code, click run. And that's what's really cool about this little preview is it's faster for students to see changes quickly instead of switching tabs. So that little preview down the bottom, we can see Lewis just used set the color to black, use the fill oval command, and was able to add an oval over there to create an eye. And there's lots of documentation about how to do some of these basic things with Java graphics. And this project, this smiley face project, you can actually download that right from Coding Rooms today that Lewis has provided you by clicking the download button in the files area of your workspace or the presentation one. So if you'd like to kind of mess around with this more on your own later on, or be able to take this to use as a project for your class, you can do that very easily just by downloading these files that Lewis has provided us with today.
For those of you who use the A+ curriculum, he has 3 graphic projects. They learn to do arcs and ovals with smiley face. Then they do rectangles and build house. And then they combine ovals, rectangles, and lines and do a robot.
Yeah, wow. So you shouldn't have to reset the instance each time. We have a question there. You should be able to just click stop at the top. Lewis, yeah, do that. And it should, if you're talking about graphics specifically, but even with any, normal system.out, print code to the console type of things or whatever, you can go and do that. Steve, have you tried using the runner file where you click the drop down? Or what code file are you running? Or do you just click run normally? So for this one, you do have to click the drop down and select graphics runner.java. So you see, yeah, Lewis was able to add another eye pretty easily. And I would say, Lewis, would you describe some of the process of your students would be, they get that oval, and now they're messing around with some XY coordinates to kind of move it around?
Right.
Could
And
you explain to us each of the parameters of that fill oval?
yeah, this is XY width and height. And I told him, I said, before you start typing, I said, you know that the left-hand edge of the face is 210. Obviously, the eye's got to be further to the right than 210, or his eye is floating out away from his head. And so for some of them, the spatial reasoning is extremely hard. So that's why I said, let's start at 100 and just keep changing the first digit till the eye gets left to right. Change the second to go down. It is a little challenging for the people who didn't like graphing in algebra, because y starts at 0 at the top, and your 0, 0 is not in the center of the screen like they want it to be from math class. 0, 0 is the top left corner.
Yeah, and that's some of the things I think when I cover some of the graphics projects, and even in my intro course, I use Make Code Arcade, and so you use some other kind of game things. Is most of these libraries work, the origin is the top left-hand corner, and as you move down the screen, the Y coordinate increases. So the Y-axis actually points down. So that's one of the things that you usually cover, because in math class it's different, right? So that's if you're looking at teaching graphics and you haven't done that, that's one of the things to cover with your students, is just how the coordinate system works.
And then
So yeah, you may have noticed that Lewis was using some default colors. Notice he called to this library color and used the black. But you create custom colors, RGB color values, which is another great lesson to go over with students about RGB color values. And you can create, and it's also, if you're teaching Java specifically, a great thing to cover instantiating objects. So he just created he's using data type color and creating a new color object with those three values.
now you see the eyes change.
So there are some really cool things that you can do. I'm actually looking to do more of this in the AP Computer Science A curriculum when it comes to, there's the unit about just using objects that you're supposed to cover in the new C, course overview. And I'm thinking about doing a lesson where we do a couple things with this, so that it's kind of a fun way to use objects.
There are several tools. I am the dinosaur on my campus. I am the only faculty member without any Macintosh equipment. Our students are one-to-one Mac, but I teach in a PC lab. So online has been great. One of the few tools that I use is a little Windows freeware that you can go. I had a kid who was an Alabama fan, go to the University of Alabama website, take the color tool, and it's an eyedropper like you see in the art program, but it's this utility generates HTML color codes, RGB, CMYK. You drag it out to the color you want, you're getting a preview and you release, the RGB values are there. And so once I found out and made it simple for the kids to be able to create a custom color, I teach them it. I have it on the desktop of their PCs. We did find a few websites. I had one kid who found some art program on his Mac. In all paint programs, you've got the dropper where you can match color. And So he managed to have his paint program, but get the dropper to go outside the boundary of the program and get a color off of a website.
What I like to do is Google search actually has a cool thing. If you look for a specific color, it actually has a color picker right within Google search, which is pretty cool too. So I kind of show students that because it's a really easy way for them to get that information even on a Chromebook.
And one of the things you can throw in when you teach the kids color is that for all of the things that technology will change, the one thing that you will not see change ever on the computer is the color depth on video cards. A trained artist can distinguish about 2 million colors. A trained interior designer about the same. The average person about 1.4 million. The problem, your computer can make 16.7 million. Your computer can generate a screen full of whites or grays that it knows are different, that you're hard pressed to tell apart.
All right, does anyone, I know Lewis, you got to get to something also. Does anyone have any questions for Lewis before we move over? To check out Python. Lewis is a great resource, and you can find him active on some of the computer science Facebook groups. So he's great to reach out to if you have any questions about Java graphics and doing some of that stuff with students.
You can also introduce the RGB values when you get to the College Board's Pick Lab. You can actually program it to go through and replace colors.
Awesome. Thank you so much, Lewis. Any before Lewis goes, any questions? We are going to move over. We're going to showcase Python a little bit and some other things. And so if you're maybe still getting comfortable with coding rooms, that's quite all right. Mr. Lindler and Noah are going to bring us through some more stuff. Well, thank you so much, Mr. Fleming. We appreciate your time. I'll get anybody in touch with you if they have any questions.
I see a few familiar faces I know from AP reading in different places, and I'm the old fossil of the Texas Panhandle. This is my 27th year as a CAS teacher. I started in the days of the really ugly green Pascal book. Have a good evening.
All your many years. Have a great evening.
All right, Joe, you ready for me?
Absolutely. So we're going to hand it over to Barry and Noah, and then they're going to walk us through doing some cool stuff in Python. I think you guys are really going to enjoy Noah's library here. I'm going to put in the chat a new live classroom for you to check out. So you can open that up. The old live classroom you can leave open still too. So if you didn't download any files or you just want to check that out still because maybe you teach a Java course, feel free to have that open. Noah, just so you know, we can see your Discord. So you just share the whole screen.
I didn't share. I think that was on there.
Oh, okay, sorry.
Yes. Yeah.
So open up that live classroom. Again, you can either click continue and you can log in without an email or a Coding Room account, or you can click to actually log in with your Coding Room account. Very easy. You can log in with Microsoft or Google. So go ahead, take it away, Barry.
Okay, great. In this particular one, I'm going to show you just a little bit of overview for coding rooms, what I do with my students, just to get them familiar with the interface, and then hand it over to Noah, who's going to lead us through our session. What you're looking at now is the main editor window, like we were just in, and you're looking at my presentation. And up near the top, you have your workspace. I have an additional tab called Student Workspaces, where I can actually click on this and I can see all of your workspaces live, and I can actually interact with them. So if I'm going to help you, I can make some edits to it, or you can ask me to look at something. I can just flip right to it and look at you individually. And like I said, I have full editing capabilities in that particular window. Also in the presentation area, I've preset files just like Lewis did. And I include usually some kind of README or some written directions as well. And you have full access to those when you, in your workspace, you have a copy of my directions. But if you'll go back to the presentation tab, my presentation, one thing I did want to point out to you is even though it's my presentation, you can independently move through that as you want to, which in most situations, I don't do a full program with this way, but it's helpful for that student that's a little bit slower and sometimes just needs a little reassurance that that code is there, or if they're missing something, they can kind of scroll back up or back down and look at it. Now, I've also given y'all extra rights that I don't normally do. You can set this particular window up to be like a co-share window. So I don't want you to, but in this situation, you can actually go into my presentation and you can actually edit the code live that we're all looking at, not just your personal copy. You can edit the master copy. And that's really good when we're going over things, or in a situation like this particular assignment, which was intended to be an introductory assignment. We would have done this together, and I would ask students to take over and fill in some missing pieces or try to reapply something I just shown. Another neat thing about the way Coding Rooms is set up is, some of you already found it, but right beside the run menu, the little drop-down arrow lets you choose which executable file you're going to run. So that's kind of nice that you don't have to recode anything. You can just select which file you want to run. And you can also, over here on the left is a little settings wheel. You can set it to whichever file you want to run. And so had I sent out an assignment or something with multiple files, I would have preset the default file so that students would know exactly what we're intended to run. But what we're planning on doing tonight, when I hand it over to Noah, is fix it so that you can have my presentation on one side and your workspace on the next, and he's going to walk you through. And if you would like to, you can do what he's doing. Now he's going to go a little bit faster because of time, and what he's going to do today, we would take probably a whole class period to do, but he's just going to kind of walk you through it. So feel free to code along as you want to. If you don't want to code along, you can just copy and paste, which is absolutely okay in this situation. And at the end of the night, we're actually going to talk about how we leave the live classrooms technically on, so you can actually go back into the live classroom later and get more information or access your work there, as long as I don't actually terminate that live classroom. All right, so do you have any questions about the overview of how Coding Rooms is set up before I turn it over to Noah? All right, let me give you a quick introduction to Noah. Noah is an amazing junior of mine. I met him as an 8th grader. We have an honors magnet STEM program at our school. We accept about 60 to 80 students a year, and he was selected. We instantly hit it off because of his interest in technology. I think you're going to be just as impressed with this young man. He never lets me down. But as you will see, if you happen to look at the README, my directions are scaffolded. So they kind of have like a beginner level. And then I've got bonus stuff at the bottom that more advanced students can do. Well, Noah will always go to the bottom, and he will never follow directions. He'll be close, but he'll do it his own way, which is good, which is one of the reasons I love him. And what we've done with my older students, or what I typically do, is I have them teach my beginning classes sometimes, whether it's just 1 unit or 2 units. And I think you'll notice with Noah, that it's made a difference for 3 years that he's been in front of the classroom, as well as behind the desk. He's also been in front of the classroom for us. So Noah, I'm going to stop sharing and let you take over from here.
Okay.
Okay.
Let me just see if I can get this going. All right, Coding Rooms. All right, am I sharing the right screen?
Yes,
Looks
sir.
great.
Okay, so if you look in the directions, you can should I run the final one, or are we just?
Yes, sir, I would. That's how I normally do it. I kind of show what we're going for.
Okay, so I'm just going to go ahead and go over here into my own little workspace, which is cool about Coding Rooms. I can just come over here and grab this final file, right? And one thing you are going to have to do, though, is as it's a library, you're going to have to use the Python module installer. So we'll go over that in a second here, but I'm just going to make sure that it's already here before I run it.
And I always include special directions like that in my directions with students, even though they know it. I tell them.
Right. So if we just go ahead and expand this desktop here from Coding Rooms, we can see. So the idea of this program is you have some boxes that are moving down the screen, and a little launcher here that you can use to make the boxes kind of like explode. So, and then then we win. So that's pretty much the idea. Just a simple like a graphics program that's interactive, uses input, and animates stuff. So anyways, without further ado, we're just going to hop into the presentation here, and we're going to go ahead
and what Noah did, he's pre-staged some solution files, which as the presenter, your workspace is private to you. So he's able to pre-stage some files in there that students can't see in case he gets into a bind or something happens. He has those as a backup.
Yeah, great thing to know that your workspace as the teacher or the presenter is private to you, just like all the students is private to them. Other than the fact that because you're the teacher, you can actually click on student workspaces to see everybody's. Actually, no, could you do that for a minute quick for me?
Yes, yes. So we can go over here and just give it a second to load here, and I can go ahead and I can see everybody's code that they have written here. And right now you're all stuck on the template that was preset. So Coding Rooms automatically, distributed some template code so that y'all have somewhere to start with us.
All right, and notice you also still have your copy of the instructions, and now you have your own private file library too. That Noah, can you open up one of the file libraries for one of them?
Yeah, over here, right?
Yeah, so if you decide to make additional files for you or a place that you want to write some notes, that's just for you. And of course, as the instructor, I can see it, but it's a nice little feature. And then again, you can interact with your students back and forth. Yep.
Okay, so it's just a little showcase of Coding Rooms running graphics well, and this PyDraw library that I've made to sort of add a more object-oriented approach to graphics in Python. So the example we saw earlier, we had some boxes, right? And so we've gone ahead and gotten ourselves a nice rectangle here, and we can go ahead and run this, and you guys could follow along here. We're just gonna go to your console and make sure you type pip install PyDraw in your own workspace, and you should make sure that your this PyDraw. Right now it's on 135. Okay, so yeah, somebody's typing it in my workspace. Make sure make sure there's a little white line underneath the my workspace at the top, and that you're not tabbed into the presentation. But yeah.
And remember, I normally turn that off for my students. I just had it on tonight, and just in case we wanted to do anything live together.
Right.
Yeah, so even though all of you can edit the presentation workspace, which is a really powerful tool in the classroom to have the class collaborate all on one thing, you can turn that off for certain lessons so that students can't interact with your presentation. So that's you can enable and disable that feature.
All right. So now that we know that we have it installed, right? And of course you would have that in some directions, and you would have to maybe help a couple students with that. We can go ahead and just run our file. So I've opened up our desktop here and I've run the file. And if you can see this, right, we have a nice, just our little red box sitting there. And you can see, like we actually was mentioned earlier, that a lot of graphics programs tend to have, so yeah, if you're pressing start and stop again, make sure you're in your workspace. If you can see that the position of the rectangle is the first two parameters that we've passed into this constructor here. And it's also top left anchored, like we saw with Java, and with the y-axis increasing as you look down on the screen, right? So the further down on the screen, the higher the y-coordinate will be. And it's just to create, a consistent coordinate system that's pretty easy to see in the code and then map out onto a screen. So right now our rectangle's just kind of sitting there, right? But we are going to go ahead and have it move. So I've already gone ahead and set up a nice animation control loop for you guys. And you can see that it's got some default variables. And what we're going to do is we're just going to go into this while loop here. Again, make sure you're in your own workspace if you're going to add stuff. And we're going to go ahead and we want our box to start moving, right? So we're going to move, the way you move the box is by calling a method on it that box.move. So, and we want it to move to the right. And so like in Java, it's going to be a positive X coordinate towards the right of the screen. So we want to move on the X-axis, maybe 5 to the right and 0 on the Y-axis, right? We only want to be traveling on the X-axis. And what's another thing that's great about Python and PyDraw is you can actually just specify the distance X equals 5 instead of 5, 0. It's more specific and it kind of saves screen space, reading, it's more readable and such. So we can go ahead and actually run this. So I'm going to stop it and run it again. And we can now see that the little square is shooting across the screen. And of course, it eventually disappears. So that's great, right? And the box is moving and it's running really great, smoothly. For moving at 5 pixels at the frame rate we have set at, which is 30, right? But we want the box to bounce around the screen. So I'm going to go ahead and add some code to have the box bounce. So we can access the box's X coordinate with box.x, right? Just a method that you call to get the X coordinate. Now, like the screen, the box's location will be top left anchored, like we saw up here. So our X coordinate is actually going to be technically referring to the left side of our box, and the screen's left side would be at 0 because it's also top left anchored. So, and then we're also, so that's bouncing on the left side of the screen, but our rectangle is also going to hit the right side of the screen. So we'll also want to take our left side and then add the width of our box by accessing the width like this with box.width. And we want to make sure that that's never greater than the right side of our screen, which would be 0 plus our screen's width, or in this case, we'll just access the width like this. So it's fairly consistent. And right here, we want the box to change direction. But right now we have the direction hard coded in. So what we're going to do here is if you just come above the while loop, and I'm going to set direction equals 5. Now I've added a plus just to indicate that it's positive because it's going to be flipping from positive to negative, but having just a 5 there is the same. And what we're going to do here is instead of moving by 5 directly, we're going to pass in this direction variable. And then if the box collides with either of the sides of the screen, we're just going to flip this direction. So you can just set the direction to negative direction. And then what we will do is also, you may have seen, the box will move down so that there's sort of a time limit on the game, right? Once the boxes get all the way to the bottom of the screen, the students, the game is over and you've lost unless you've destroyed them all. So what we're going to do is we're going to use this .move method again. But instead of using dx, we're going to replace that with dy. And we're going to move down on the y-axis. And remember, dy, dx, distance, x, distance, y. And we're going to move down, since our box is 25 pixels and our starting margin was 10, I've picked out a 25 plus 10 or 35 as the distance to move down. So that's how that number is there. You can, of course, just put 35, but I'll leave it as 25 plus 10 to just be clear. And so right now what will happen is it'll move our box and then it'll check if our box has gone out of bounds and it'll flip the direction the box will move when on the next cycle. And it'll also move our box down. So we can go ahead and run this and watch our box move across the screen here. And we can see it bounce and it moves down. Very snake-like, slithering almost, where it's just going from left to right and then moving downward slowly. It's exactly what you want. It's kind of reminiscent of some sort of Space Invaders kind of game. If you're,
yeah, but I'm going to interrupt Noah real quick. Just notice in the chat, I forgot to mention or reiterate that what you're seeing in PyDraw, Noah created. When I taught him Java, we used a thing called object draw, and during the pandemic, we needed something a little bit more robust for us to use in Java, and we were switching to Python for other classes. So he decided to write a graphics package that was much easier, much more consistent, and quicker to get students on board. So he's created everything you've seen. We spent hours debating style and whether it should be this or that, and even the sleep calculation. I just remember that was like a 30-minute argument about what the formula should be. But this is all his work, and that's why he's showing it off.
All right. So yeah, as you can see, somebody's also run our presentation again for us. So you can see that it is moving down, and that is great. The animation looks pretty smooth, and you know, overall, I think it's looking pretty good so far. So next up, we're gonna do possibly the most fun part of this assignment for anybody, is starting to make it interactive. So we're gonna add that launcher that we saw earlier, and it was just a little black rectangle that seemed to follow the mouse around, right? So this is possibly one of my favorite parts of this assignment specifically, and in general, like with Python and PyDraw. So we're gonna go below our screen here. If you just about line 3, below line 3, right, the screen, and we're just going to create another rectangle called launcher. So you'll do launcher, and we're gonna make a rectangle, and we're gonna put it on the screen. So something that I didn't mention earlier is that the rectangle, you do need to tell it the screen to draw it on, right? And we have a screen, you know, and we don't need to get too much into it, but there's a screen, and we're going to make sure we're telling it to draw on that screen. That's important if you want to see it on that window. And so the place we're going to keep this at, the place we're going to put this is the bottom center, right? We want it all the way at the bottom, but at the center on the x-axis. So the x comes first, so we'll put it at screen.width divided by 2. And for the height, we're going to, or sorry, the y rather, my apologies, sorry. We're going to put it all the way at the bottom, right? So we'll do screen.height. So, and then in terms of width and height, I'm going to go ahead and give you these values. 50 and 300 are really good values to use, because that's what I'll be using. So for the width and height, make just 50, 300 should work really well for y'all. And what we're going to do is we're going to, so we have to think about this, right? The boxes, the rectangles and everything is all top left anchored. So the position that we've put in is screen.width divided by 2 and screen.height, and that's going to be the location of the top left corner. So what we need to do is this 2-step process in centering the launcher. So we're going to do launcher.move like we did with the box, but this is just a single move we're calling right below our constructor to change it from the left corner being at those coordinates we passed to the center being at the coordinates that we passed. So we're going to actually need to move by the launcher's width, but in the negative direction, right? Because it's top left anchored and we need to move the center. So we're going to go left on the x-axis. We want it to move left. So we're going to use negative. And we also want the height. We're going to do the same thing with the height, right? Launcher.height divided by 2. And this is just the process of centering an object in most libraries. There is another way with, you can use launcher.center, and we're going to see that method in action a little bit later on. But this is a really common way that you'll see centering done. And so yeah, we've got our, so if we go ahead and run this now, I'm just going to go ahead and do a little test run here. And we can see now we have a nice little like pipe-like launcher sitting here at the bottom. And it seems to be well positioned and ready for action, but we need to go ahead and get it moving. So this is my favorite part by far, is the input. And the way input is done matters a lot to me, because I've seen it can make the difference between, you know, when you have the difference between a static images and interactive games, you could call them, or programs, is really immense. There's it adds a lot when you can have the code be interactive and then the program, you know, produce an interactive result, because, you know, a lot of people play games, especially students. So, you know, it's good to have that sort of effect. So what we're going to do here is we want our launcher to follow our mouse. So the way input is done is you're going to create a method called mouse move in your file. And mouse move, it's going to take one parameter called location. And that's just the location that the mouse is at when this mouse move event is called, which is called whenever the mouse moves, right? So when our mouse moves, we want our launcher to point towards our mouse location. Now, if you stop for here for a second and you think about this, in most situations, you would have to do some sort of arctangent, some inverse tangent to pass in the position values to get an angle out, right? But in this case, since a lot of times you're dealing with, you know, younger students, and integrating math into programming is sometimes a difficult process, right? And you want to make it accessible and, you know, easy to do. So there's a nice little method we're going to use here, launcher.lookat, which will take a location. And what this will do is this will just automatically rotate, call arctangent and do the math behind the scenes so that our student only has to really worry about what their code is doing in this instance rather than how it's doing it necessarily, because the math behind it is important, but conceptually the launcher pointing at the mouse's position is what we want, right? And if we go ahead and run this, you'll see that nothing actually happens because there's one more step we do need to do, which is we need to make sure that we tell the screen to listen for input, because screens will not be listening for input by default. So we need to tell our screen that it needs to listen for this input. And once you call this screen.listen method, you must call it below any of your defined input methods. It will automatically scan your file completely hassle-free, and it'll just find all of your input methods that you've defined, and it will register them and call them when the event occurs. So it's a really nice way to avoid callbacks and a lot of the complex things that come with event handling in normal programming. And it's a nice, simple way to do that. So after we've added screen.listen, we can call run again. And you can see here now when I move my mouse here, the launcher is following our mouse quite smoothly. And everything looks to be in order. So that method's right there below where we declared our box.
And that's a pretty smooth graphics animation, especially for remote IDE. That's one of the reasons I really liked Coding Rooms when I first saw it.
Absolutely. So if Noah, you can run that again, actually, because some people are bringing up some other IDs, and the ones mentioned, I haven't seen them run this smooth or even render the GUI in the same way.
Right. The full desktop really makes sure that the window renders properly and it doesn't bug out. So I think that's a really good thing. It certainly fits our use case here.
And I will say before, as Noah continues, just that this is being recorded, so you can go back and follow Noah, and kind of code through this on your own after also. So don't worry too much if you're having a hard time keeping up. Right. All right. So we're going to move on a little bit more quickly to get it going ahead and getting multiple boxes on our screen. So the idea here is we're animating a single box, but we want to have many boxes that are all moving in the same way, right? So programmatically, that would require some sort of list because we want to loop over all of the objects and apply the exact same operation to them. So we're going to go ahead and instead of this box equals rectangle, we're going to want to replace, or not replace it yet, but let's just go ahead and right beneath it, create a list called boxes, right? A boxes list. And we're going to store all of our boxes in this. And then now what I want you to do is, or what we're going to do is we're going to cut this. You're going to want to take your box line where we declared the box, and you're going to want to put that in a new for loop. So I'm going to go ahead and declare a for loop for I in range 5. So we're going to create 5 boxes. And I'm going to go ahead and grab my box code if I can. I'll just rewrite it. And we'll do, it's the same type of box, right? We're creating a box that's 25 by 25 in red, but we are going to need to offset this X coordinate position so that all the boxes don't spawn on top of each other, right? So, excuse me. So what we need to do here is we need to start offsetting them based on what position they are in the array, because the further in the array we get, the more offset we're going to need to add. So what we're going to do here is we're just going to append another expression here where we're going to multiply I times 25. And this 25 here is just the width of the box, right? So for 0, we won't do this at all, right? But the second box in the list at index 1 will have 25 extra pixels added to its location so that it can make space for the previous box. But we don't want them to all appear as one big rectangle. So we're also going to add a right margin. So you can see the way I'm doing this is this 10 is the left margin for the first box. And then this 25 is accounting for the width of the previous box. And then this 10 we added afterwards is basically a right margin for our boxes. So we can have this little bit of space in between them. And obviously that just adds to 35, but I'm again leaving it there. And we're also going to want to delete that original box statement. So I'm going to go ahead and do that. So now we just have our boxes and we're creating our box. And now we need to make sure that we actually add our box to our boxes. So we're going to add our box to our boxes list like this.
And just to reiterate on there's a lot of good theory discussion that just happened there. And because of Coding Rooms, you're a slower student that is so worried about writing exactly what you're writing can pay attention to you, because now they can get to this code in just a few minutes so they can listen to you and listen to that discussion that Noah just had. So that's another reason I chose Coding Room over some other options.
But yeah, that's that. Yeah, definitely. And the boxes, so we're adding the boxes, and now what we need to do is we just need to go, and I'm scrolling down to the while loop here, and we're modifying our, we're gonna modify this, and we're just gonna put this entire statement. So you can see, for me, it's lines 26 through 30, but it might be a little bit different for you, but everything that's dealing with the box, which is all that we've added to our while loop from the original template, is we're just gonna put that into a for loop, so for box and boxes, right? And you might have to correct your indentation when you copy paste that. But other than that, we should get an interesting result here where, so we're looping through our boxes and we're moving all of them, right? And we have all our old collision checking here. So what I'm going to go ahead and do is I'm going to go ahead and run this, and we'll go ahead and take a look at the result and see if it's to our liking. And we'll see that there's this tiny issue with our code where we have the boxes, only the box that we are currently checking for collision is the one being moved down, right? Because only the left and rightmost boxes will be the ones that are actually colliding. So what we're going to do is we just need to separate this collision checking code from the movement of our boxes entirely. Now, one way that I have seen it done is they add a secondary for loop in here. So maybe you could do for box 2 in boxes and add this move in here. But you're going to see that this actually just makes it so that one box moves in one direction, the direction gets flipped, and then all the other boxes move in the other direction in the for loop. So you'll see that a big gap gets built up with the left box specifically. So what we're going to need to do here is we're just going to, hold on, let me actually just get the code back here. And what we're going to do is we're just going to move this code outside of our for loop, and we're going to just define a left and right box. So our left box will be the 0th index, and our right box will be at the last index of our boxes array. So we're just going to access our left and rightmost boxes like this. And now instead of comparing every box, we'll just compare the left box for this left.x when we're comparing the left side. And for the right side, we're going to just change this box to a right. And the idea is our right box will represent the right side of our total entity of boxes, our collection of boxes. And then this left box will be the left side. And we're just going to, instead of doing box.move at all, now we can put this in a for loop. So I'm going to add a for loop here for box and boxes, and this will move all of the boxes down. And I'm going to go ahead and restart our program so that we can see this correction taking place. And we can see now the boxes are all moving in order. Okay. So we're going to hurry and make sure we just, so the last thing we need to do in our program is just add the projectiles that we saw, right? So the firing of the projectiles is another fun thing. That's a pretty common common theme that you would see in most games. So it's another very encouraging thing for students. And so what we're going to do is we're going to add another input method. So our fire control is going to be the mouse button. So we need to check for when the mouse button is pressed. So we're going to do mouse down. And mouse down takes a button and location parameter. And what we're going to do here is when we press the mouse button, we want to create a projectile. Now, like our boxes on the screen, we're going to have a lot of, we might want to have multiple projectiles. So we're going to have to create another list for this in a second here, but I'm just going to go ahead and define our projectile like this. We're going to create it on the screen, of course, and the position is going to be not the mouse's location, right? Because the launcher is pointing at our mouse location, but we want to actually create this at the launcher. So this is an example of that center method I mentioned earlier, where we can actually get the center of the launcher by just calling .center. So I'm going to get the X and Y coordinates of the center of the launcher, and this Y should be there. And we're just going to do that. And then we're also going to have our projectiles be 10 by 10, and we're going to set their color to green so they're nice and visible. So yeah. We've created our projectile here, and the next thing we're going to do is make sure we add it to a list. So we're just going to go here, and beneath our boxes list, we'll create a projectiles list. So I did that right beneath our boxes list, and down here we'll go ahead and add it. So projectiles.append projectile. And so this is where we're going to see another great thing about PyDraw, and that is the ability to travel in the direction that it is currently rotated. So this is again avoiding more sine and cosine, some mathematics that would normally be required. So we can just have our projectile, we can set its rotation using the rotation method, which would retrieve the rotation, or if passed a parameter would set the rotation. And we're going to set the rotation to our launcher's rotation. So projectile.rotation to our launcher rotation. And now what we're going to use here, and I'm just going to show you all here in a second, is we're going to use this dot forward method, which will automatically use sine and cosine to calculate a dx and dy for our angle. So I'm going to go down into our while loop, and we're going to add another for loop at the bottom here, but above the screen.update and screen.sleep. That's important. And we're going to just loop through our projectiles and call projectile.forward 10. And so 10 is just an arbitrary number I've chosen. It's a good speed for them. They're very visible that way. And you can see that I did place this mouse down method above the screen.listen. So what we're going to do is just go ahead and run this and see what happens. We can see that when we click now, and that's running pretty well, and it's running good actually. And we can see that we're just creating these projectiles. Now remember this, there's actually half of our rectangle is actually below the screen. So you can see that it's actually being created at the what we see as the base of our launcher. And they're being created, and they're just going in the direction that the launcher has. And you don't need to worry about it much more than that. And so yeah, that is the projectiles. And then lastly, we want to do something when the projectile actually hits a box, right? So after we move our projectiles, we're going to do another sort of check here where we're going to loop through our boxes, right? 4 box in boxes. And we'll just do if, now this is another neat thing, if projectile.overlaps with our box. So if this is just a really useful method, because a lot of games involve like some sort of collision, and this is the quickest way to detect that, right? If it overlaps with our box, we're just going to want to do something. So in this case, we'll just set the box's color to a new color. So what's cool is you guys have seen me using this color class, right? Where we've been passing strings. This color class also takes a red, green, blue. So we could, for example, change it to 133, 177, 133 as an RGB instead of maybe passing it a constant, a static string. So it also works with hexes, but you'll find that RGB and just strings are the most common. So we'll go ahead and come back here and we'll see what happens when I fire. And you can see that it's a nice little green color that they get changed, and we hit them all very quickly. So that was nice. But yeah, you can see that the overlaps is working well. It's causing no lag at all. And we've now changed our box's colors. So that's a neat thing to do, but maybe we want our boxes to do that animation thing because we want to stress, maybe having some slight complexity. And this is just another bonus thing, but we can add a little quick animation here where we actually make the box explode into a bunch of particles. So what we're going to do here is before we do anything, we're just going to remove the boxes when we hit them, right? And you need to make sure that you also remove them from the array. So we're going to remove the boxes from the array also when we do that. If you don't remove it from the array, you might try to call this box.move on a box that's been removed. So it's very important that you remove it from this array. But yeah, and then of course, we're also going to do the same thing to the projectile. So projectile.remove and projectiles.remove projectile. Now, generally, this is a semi-bad practice to be removing elements from an array while you're looping. But in this case, since we're running at a frame rate and this loop is going to get called again in the next, millisecond, it's not really important that we might gloss over a box because the simplicity of the for each loop is well worth the very slight performance decrease that we might experience there. And so we can go ahead and see now, if we go ahead and run our code fully, that we should be just removing our boxes and projectiles once we hit them. And we're going to see one last error that we're going to fix here because I think we're running out of time to do the animation here, but there's one last bug that you're going to want to fix if I can hit this box. Hopefully we got, oh my gosh. All right, we'll hit it. We'll hit it. This is just sad.
It is sad. You wrote it. Where's our cheat code? We need our cheat code.
Oh, we hit it. All right, finally, we got the error. So you can see that we actually hard-coded accessing indexes or indices of the list, and that's going to cause issues when your list has nothing in it. So what we just need to do is we just need to add a quick state. So we're going to check for our win state. I'm going to do my best here to copy this. Oh, thank you. And what we're going to do here is we're just going to put this in a nice if statement. So if the length of our boxes array is not 0, now of course you could also put greater than 0 here, but since really we want to make sure it's not 0, I've just chosen to use not equals 0. There's not really a difference, except we're not really checking for a range here. There's just a very specific value we don't want. So it's just a sort of a specific thing, but of course greater than would work. And now in our else statement, we are just going to do something for when they win. So maybe we'll print you win, and we can go ahead and run this, and hopefully I can destroy the boxes much more quickly this time. And you might have seen that last time we ran it, that it was getting a little bit slower each time, and you can see now it's spamming. And that's just because we're not actually, cleaning up these, when we remove them from the screen, we remove them from being computed when the screen is rendered, but we're not removing them from memory. So theoretically, enough projectiles would be would slow down, but it's not really a very big concern. And of course, all you'd have to do is just remove them when they go off the screen for the ones that don't strike boxes. And that's pretty much it. The last thing I am going to show is just the quick creation of text. So another great thing about this, the library, at least I think, is we can create text really fast. So we just call in this text right here. And the most important thing about a text is the text it displays. So you'll see we're going to just put like maybe a you win here. And the position, we'll just put it at that 10-10 margin that we used earlier, because the boxes shouldn't be at the beginning if they're winning. They should at least be somewhere along there. And now we also want to give it a font and a color, and the constructor for this includes a lot of different things like italicized, bold, and frankly, it's a little difficult to remember everything. So I often would just use these specifiers. So for example, for the font size, we can just set it to 32 like that, and we can specify the color like this. And I chose a random color that I thought looked really good, but 127, 133, 155. I'm just picking random stuff, and of course you could also put color.random here is a neat method where you can get a random named color. So this is not actually a random color between the ranges of 0 to 255 for each specific primary color, but it's rather just one from the library of about 170 named colors. And so I'm just going to go ahead and try it and fail to win this game again, and hopefully we can see. Yep, there we go. One of these is going to hit it. There we go. And now you can see that's a little epileptic, but you get the point, right? Because it's just going to keep running the loop and keep creating new text. So maybe it's better to have the text be a singular thing. But if you like the animated text, that's cool too. So yeah, that's pretty much the whole program. We didn't get to everything, but this is really the main gist of it. The last thing we would have done is create an explosion, but I am gonna, I think, make public. There's going to be a final file where you guys can see everything.
Sure. And and I'm going to just kind of wrap it up. So if it's something you want to be typing as we do it, but Noah, this is awesome. When Noah first started showing me this a couple weeks ago, and as things kept growing, I could see the benefits of it in class. He's an exceptional young man. You can see he's a good teacher too, and he's very passionate about the way he does things, and I certainly appreciate that. And as some of us were, I think Steve and I were having a conversation in the chat. I was not a Python person until the pandemic. And then I started looking at other things, and the pandemic opened my eyes to a lot of options. And now I see that there's so much I can do. I actually use Python with my first year students, then Java for APCSA students. APCSP students can do whatever language they'd like. And then I have a fourth year class, my computer programming 2 class, and they're using Python too. So it's kind of starting and finishing the process. And so even my more advanced students are doing some amazing things with it. And we were talking about the documentation. Noah spent a lot of time writing documentation and constantly fine tuning it. He's got a website I listed in the README with several working examples that you can use. But I encourage my students all the time to look at the documentation. And in fact, what they do is they'll open up coding rooms, and another tab will usually be the documentation. So if they have a question, first thing I'll ask them is, did you check the docs? And if they didn't, they've got to look at that first. And then, just like we all know, the more they do that, the more they're picking up tips as they go. But Noah, this is fantastic. Certainly appreciate it. And thank you for your time showing it to us.
Yeah, no problem.
And he's
no problem.
he's also got a companion graphics library for Java called JavaDraw. Works very similar, and his whole goal was to make things consistent and easier for the students to get into this, so you can have those bigger brain discussions and not get bogged down in where that semicolon goes and exactly the structure of publish edit void main, and you can just get to work.
Right. Yeah, the main idea of it was to try to make it as close to PyDraw as possible. So it was very translatable. So if you wanted to have assignments in PyDraw and you wanted to also do something similar with Java, they're very, very close in their syntax and the way the methods work. Now, this is very Pythonic with using X as an accessor and a setter, but there's also a version where it uses get set if you wanted that specification for maybe some AP students that you don't want to confuse with the whole getter setter Java stuff.
Yeah, we had that debate for a good day or so about how to do that. So the Java version is JavaDraw.
Yeah, if Barry or Noah, if you could put your docs for JavaDraw or GitHub repo or something like that, I'm sure if you have it available there, people would like to look at that also.
Yes.
And like I said, they both are in the README, and I'm posting them also in the chat.
Oh, excellent.
Yes, JavaDraw's documentation is work in progress because JavaDraw itself has been very recently constructed. I've been, busy with school and stuff, but its core is it's all there. And I have a jar for it. I'm just not comfortable releasing it without making sure it's really solid. So, but you can see that there's some links to a separate website. So you see pydraw.graphics. There's also javadraw.graphics, which will be up in the coming week, I believe. So that will all be there and settled. And of course, you can always access that through Pydraw's website, given that they're sister libraries. So yeah, that's how you guys will be able to see that in the next week.
And it's been really impressive to see the big brain conversations they've had on like rotating objects and all the math behind getting those things to spin around. He couldn't show you all that, but I've seen him work hours on this, not doing his U.S. history, but doing this instead. So.
I may be biased, but I prefer him to work on this.
Absolutely, history will be there for a long time.
Forever, really.
That's right.
Any questions for Noah? Barry too, but Noah's more important here.
Absolutely. Thank you, Ms. Fisher. I appreciate that. No, I don't know if you saw it. She's just saying it was an amazing presentation.
Oh, yeah.
And Steve saying train us.
Let me go ahead and stop.
They want more Noah.
Thank y'all so much for humoring me.
His head barely fits in those headphones now. Y'all need to be careful.
So thanks everyone for sticking around to the end. I do have a special surprise, especially for those maybe you're already using coding rooms or interested in it. At the end here, one of the things that Sasha and the team have really been working hard on is integrating Visual Studio Code into coding rooms as an IDE option. So not only will you very soon, I believe Sasha's telling me, have the option to select just the normal coding rooms IDE that we've been using tonight, but you can actually use Visual Studio Code right in the web browser. So I'll show off some of the benefits of that. Mainly, it would be a preference, but Visual Studio Code does have some little tricks to it that may be useful. I actually was using Visual Studio Code as the IDE with my students in the computer lab prior to starting to use coding rooms. So this is a really cool thing for me. Steve, I promise it will make sense once I share my screen. All right. So over here, we do have a workspace open. And as you can notice, this looks a little bit different. I am on coding rooms. Can someone confirm for me, because for whatever reason it's not showing any border, that, or Sasha, maybe you are seeing Visual Studio Code?
Yes.
Yep, okay, yep. Excellent. So over here we do have coding rooms with Visual Studio Code, and I have a project set up. Notice we have, you know, a lot other coding rooms things, sharing this workspace, etc. And I do have a Java file set up here. And if you're familiar with Visual Studio Code, you can go into, you know, settings. And for instance, I have a dark theme selected here, but we can change that to a nice light theme. And so you have some of those customizations. Some of the benefits also, just to quickly look, is we do have extensions that you can use as part of Visual Studio Code for some different things. For example, here I have a Java project open, so we do have some of these, for instance, the debugger for Java and some of the other project management support that you'll get with Visual Studio Code. To run this file, I can just click the run button up here, or one of these extensions adds this nice run or debug option. And it's just going to open up the terminal in a familiar way of using Visual Studio Code, but this is just the coding room's terminal opening up to run that. And notice I have my Hello World program here. And of course, we do have graphics support when using Visual Studio Code also. And so if I go over, anybody use CS Awesome for AP Computer Science A? One of their libraries that they have is for Turtle for one of their units. So I have a little program here that we can run. This is using the library from that. Okay, it's running. I can just view desktop. And now I'm using Visual Studio Code, but I still have my desktop over here to check out my little Turtle program. So same as Coding Room's IDE. It should, I think Sasha and the team have worked really hard to make it feel like the excellent Coding Room's experience, but now you're just using Visual Studio Code instead. Some of the things that are advantages, kind of what Steve was talking about, is we do have a debugger. So if that's something you really want, you can use the debugger. It does have intelligent code completion. So notice I said YRTL, and it knows the methods that belong to this data type of a turtle object. So that all comes up, which is really nice. So you get all that really good intelligent code completion as part of this. And when it comes to using jars and you know, these external libraries, Python, of course, is really nice with handling these other packages and importing them. Java can be a little more complicated with kind of setting that up. And you may be more familiar with IDEs that make the experience really easy. Coding rooms, you do have to kind of do a custom run configuration to get the jars to work just right. But Visual Studio Code, if you've used it for this before, you can just simply create a folder within your workspace called lib, and Visual Studio Code for a Java project will look in that folder for any libraries you'd like to use. So for instance, because this is in this lib folder, it knows that world and turtle are a data type that is appropriate to use within this project here. If I pull this turtle library out, this jar out of that folder, notice I get some error messages now, because now this project's no longer using that jar. So it cannot resolve this particular data type. Once this jar is in that lib folder, again, all that intelligent code completion and error checking, Visual Studio Code does a little bit better job of that. It works beautifully there. So it knows those data types exist, gives students those error messages before actually clicking the run button. And again, like I said, the intelligent code completion will understand the methods that belong or that are in the actual classes inside of this jar. It looks and has some more intelligent features like that. With the debugging, you add your breakpoints and all those good things. So it is a more professional, fully polished IDE. Do you need it for probably most of your classes? Probably not. I think the Coding Room's IDE does a fabulous job with most of the things you'd want to do with your classes. But if you are interested in or missing the full power of some of the IDs maybe that you were using locally, this is an excellent thing. All your assignments, the live classroom, and everything else that we're seeing on Coding Rooms and all its wonderful features now will still work, and your students will have access to Visual Studio Code. I don't know if Sasha, you want to say anything in addition.
Yeah, sure. I want to mention that, and perhaps Joe, since we have some newer folks, and can we see the student dashboard maybe in one of the classrooms that we used for the webinar?
Yeah, with Visual.
No, just maybe without now, since it's not shipped into general
Okay, that's what I was.
availability yet.
All right.
But one of the cool things is that you will actually be able to use the Visual Studio Code with the live classroom. So your students can all be using, like Visual Studio Code, but you will still see our statistics on student activity and also the statistics on whether or not your students are working. And then you can also view their code in our simpler IDEs. So you can line up to 18 students at a time in one list. So you can scroll through to see which students are working, which students are asleep, that kind of thing.
Barry, actually, if you could share your screen, because you have a live classroom populated with people, it will be best to look at that.
Okay.
Sorry, Sasha, to interrupt.
Yeah, no problem. I think, oh, and then one other thing I want to mention with VS Code is we still update all the user edits in pseudo real time. So with VS Code, it'll be every few keystrokes. So you can view the playback of any student's work much the same way that it works with the current Coding Rooms ID. So Joe is showing the dashboard and the little, for example, Sean Kenner, you can see active 15 minutes ago, and 26 times ran the code, 8 times an error occurred. And that was in the last 5 minutes of editing there. You can see event history, things like adding files will show up in the event history. And then you can play it back with timestamps as well. So this is kind of, as far as I'm aware, there's nothing that will be more granular than this kind of level of playback. And as part of this playback, we're working on a plagiarism detection solution that will take into account not only the actual code that the students are using, but also the pattern in which they develop it. And so we're currently training that on our set of student work that we have. And so that'll be another new thing that you'll see in Coding Rooms in the relatively near future.
And if anybody, because visually you're not seeing that, didn't comprehend that all of these features that he's talking about, we're seeing with the Coding Rooms IDE, even if your students use Visual Studio Code, you will still see that granular changes in their event history. You'll still be able to check on their code and see it in real time, add to their code, in a number of things that will update throughout those IDEs.
Yep. And also, if you go back to the VS Code window that you had open, I don't know if that's readily accessible, but
yes, no problem.
You can actually switch between Visual Studio Code and the Coding Rooms ID. So students can swap between the two. And so to access features like playback, you just click the little back button in the top left. Yep, back to Coding Rooms IDE. And so it switches back fairly quickly. And then in the settings, you can.
I have the jar set up, especially for Visual Studio Code.
Yeah, let's see if we can update that. I think we kind of
previously. I deleted this. I had a configuration set up for running in Coding Rooms, and I deleted the file right before, which is sad because then I could have shown how it could have worked in either one. But I did have an SH file that was set up specific for that.
Yep. And so if you go into a file like Turtles, I think you edited, right?
I did, yes.
So if you open up Turtles and then hit the playback, then you should be able to see some edit history there as well. You can
Yeah, so
see
you may have seen, so this particular call, I said uRTL dot backward. And you notice that there's a jump there. And remember, if you remember also, I didn't type backward. I selected it from the intelligent code completion. So it just pops in there. But notice it's still tracking that for you, the teacher, to be able to go into a student's assignment and still be able to use this playback feature to kind of see the student's logic and to catch them cheating if you want, right? If they're all of a sudden like really rapidly kind of pasting in code, most likely they didn't develop it on their own.
Yes, I use this in APCSA for the FRQ parts of some of our exams, just for that purpose. And a secondary purpose is sometimes, a student gets stuck, and if you're in a live classroom and you have this feature, you can pop in there and give them a tad of a hint, just get them past whatever's just stopping them completely. But I really like being able to play back and see, how long did they spend, what did they get hung up on.
There's this run config just came back on me, so I didn't know what was going on there in the playback. So that's interesting, Sasha. I didn't know it did this. See these other older files in the playback, it's showing them. If I go back far enough, will it? Oh yeah.
You should be able to grab it. Yep.
So that's really cool. And I didn't really think about that, but great for everyone to see live on this call is even older files, which means that if a student deleted a file or something like that, you can go back into the history and retrieve it. Am I accurate to say that, Sasha? I haven't used it for that particular purpose.
Yeah. If you delete a file, it'll still be there.
That's really cool, because we've all experienced as teachers, all of a sudden a student just kind of destroys everything that was there, maybe when you have a complicated thing set up, or especially those FRQs and some AP labs and a number of things that maybe there's a lot of stuff pre-set up they're supposed to do, and all of a sudden they completely mess things up. But if somebody wanted to see, instead of using Visual Studio Code in that lib folder, what did I call this? Then have a kind of a custom run configuration. I can help anybody out with this. Runconfig.sh, I had named it. I'm now going to say for it to add to the class path this any files in this lib folder here. So then I can I'm actually going to do turtle. And then compile any of my .java files, and then I'm going to actually execute the turtle class in order to actually run that file there. So this is the kind of run configuration you would need to set up in coding rooms. And again, anyone can reach out to me if they're really interested in doing that now without Visual Studio Code. And I can help you get your jars working well. Not a problem at all. So let me kind of run this now. And so I can go to the settings here and notice I have a custom configuration. I'm saying bash. I'm just essentially telling it to run that file there. And you could each of these lines of code in the script that I've created, you could actually have them over just in this line here, but it becomes a little crowded. So I kind of like to space it out in the script so I can more easily see what's going on here. And I'm going to click on run turtles. I'm a liar. I'm going to click run because that's my custom configuration. And I'm going to do that again because I actually had the old one from Visual Studio Code up. There we go. So again, the regular run button. So I clicked the drop down. The reason why I did that when I selected turtle is I don't want to do that. I actually want to do the custom run configuration, which is bash runconfig.sh. So I just click the run button itself, not selecting a file. It will actually do my custom configuration, and it will actually run that code.